4차 산업혁명 14주 3차 시강의를 시작하겠습니다. 챕터 16은 우주기술입니다. 스페이스 마이닝에 대한 동영상을 보도록 하겠습니다.
Iron, gold, copper. Minerals are the lifeblood of the world's economy.
금과 같은 광물들을 우주에서 캐는 것에 대해서 알아보도록 하겠습니다.
From the Arctic Circle to the Sahara Desert, the $1.7 trillion mining industry
산업의 규모는 1.7조 달러 정도가 됩니다.
supplies raw materials needed for everything, from skyscrapers to smartphones. But mining also comes with an increasingly critical environmental cost, one that may require us to think about off-planet solutions before it's too late.
마이닝 인더스트리는 대단히 중요하지만 환경 오염의 문제가 있습니다.
Asteroids, moons and planets in our own solar system hold an essentially unlimited supply of untapped resources.
The first trillionaires will be those who mine asteroids.
정보통신 기술의 발달로 빌리어너들이 탄생했지만 우주 기술의 발달로 역사상 처음으로 트릴리어너가 탄생할 것입니다.
Resources like gold, platinum and rare earth metals make some of those asteroids incredibly high-priced, but the most valuable element may be our most basic one.
What you want to mine in space is what you need a lot of.
And while humans have been mining for thousands of years, mining in space requires new, innovative technologies to realize any potential business and economic opportunities. Such technologies might just allow humanity to expand operations off Earth and take that next giant leap.
우주에서의 마이닝 기술은 우리 인류에게 거대한 도약일 수 있습니다.
These tiny dots represent the millions of asteroids in our solar system. Over the past 2 decades, government and private aerospace companies have been investigating their composition, location, and even possible payoffs to mine them.
지난 20년간 소행성에서의 광물 가능성에 대해서 연구를 해왔습니다.
This one, known as Bennu, has an estimated value of $669 million. Ryugu, $82 billion. Better yet, an asteroid called Davida, which is valued at more than $100 trillion. And the reason for these high price tags? They're made up of valuable metals like platinum, gold, and iron.
다비다라는 소행성은 금과 백금 등 매장된 광물의 추정량이 100조 달러가 넘습니다.
We believe that asteroids have platinum group metals, rare earth metals in higher percentages than you might find on the moon, for instance.
Only once in human history has an asteroid sample been brought back to Earth, on the Japan Aerospace Exploration Agency's Hayabusa mission in 2010. And even then, the return sample was merely dust particles. And the total cost of that mission? Approximately $250 million.
일본의 하야부사 미션에서는 단지 먼지 같은 입자 가져오는데 2억 5천만 불이 들었습니다.
One problem is that compared to the moon, there's very little gravity. So somehow you have to attach yourself to the asteroid, whereas on the moon, the gravity will hold your processing equipment in place. So the general answer to the question, can we bring materials mined in space back to Earth? The general answer is no.
우주에서 지구로 소행성을 가져오는 것은 좋은 방식이 아닙니다.
Bringing things from space to Earth only makes sense if what is retrieved is so extraordinarily valuable and just not available on Earth.
And even returning the most valuable asteroids could drastically devalue those materials. Take asteroid 16 Psyche, for instance. NASA is constructing a probe to launch in 2022 to study the potato-shaped object.
나사는 이 소행성을 연구하기 위해서 2022년에 조사선을 보낼 계획입니다.
Which is roughly 95% metals, nickel iron, platinum and even gold. Some estimates value the asteroid at $700 quintillion.
이 소행성의 가치는 700 퀸틸리언 달러까지도 추정되고 있습니다.
NASA says it may be the inner core of a developing planet that somehow lost its outer layers, offering incredible insight into how planets are formed. If someone did manage to bring large amounts of this asteroid back to Earth, supply of the resources would skyrocket, meaning we'd have more of the material than we would have use for, causing the price to crash to almost zero.
이러한 광물을 지구로 가져오게 되면 공급량이 크게 늘어나서 가격은 0에 가깝게 될 것입니다.
Once we erode the rarity of a high-value metal or mineral, the value of that terrestrially could drop significantly.
Experts agree that a more likely scenario is materials mined in space will stay in space, jump-starting a whole new money-making industry.
우주에서 새로운 마니 메이킹 인더스트리가 만들어질 가능성이 높습니다.
Any spacefaring nation will have looked at what's called in situ resource utilization, which is a very common space term, meaning you use the resources where you are. So taking that model of if you need it in space, mine it in space, what would you be mining? Mostly you need fuel.
스페이스 마이닝에는 연료가 필요합니다. 그 연료를 우주 안에서 찾아야 됩니다.
There's something else much more valuable for use in space that's abundant on Earth. Water. Not only can water sustain human and plant life for future manned space missions, the components of water, hydrogen and oxygen, can also be separated and reassembled to make fuel. This zero-emission fuel, called hydrogen fuel, is the same used in spacecraft propulsion and fuel cell vehicles. Hydrogen fuel research in this new space race could also spur new technologies that can help fight climate change by speeding the elimination of fossil fuel use on Earth.
우주에서는 물이 중요하고 물을 구성하는 수소를 통해서 연료를 공급하는 것을 연구하고 있습니다.
And there's already a high demand for it, and an immediate business opportunity for risk-tolerant companies wishing to make a fortune. In a 2018 paper by industry, government and academic experts, they estimated that for an initial $4 billion investment in a moon water mining operation, which is about the cost of a luxury hotel in Las Vegas, about $2.4 billion in revenue could be generated annually.
The sort of business case 101 for mining in space is if you're going to launch something from Earth, it's going to cost you about $10,000 or $20,000 per kilo to get it into space.
지구에서 우주로 무엇인가 가져갈 때는 1kg당 1만 불에서 2만 불 사이의 비용이 듭니다.
So if you need water for something in space and you can produce it for less than $10,000 a kilo, then do it in space. The United Launch Alliance, ULA, they have put a price on water in space. They have said, we'll give you this amount of money for the water, which means people who are going out and trying to produce that water now have a customer.
물을 우주로 가져가는 것보다 우주에서 물을 구하는 것이 훨씬 가격이 싸기 때문에 나사는 우주에서 물을 사겠다고 제안을 했습니다.
In 2016, the ULA announced it's willing to pay around $3,000 per kilogram for propellant in an orbit less than 2,000 kilometers in altitude, called low Earth orbit, compared with the estimated price of $4,000 per kilogram to deliver the propellant from Earth. Most experts believe the moon is a logical starting point for this.
전문가들은 달이 우주기지를 건설하는 데 적합한 곳이라고 보고 있습니다.
It has more gravity than an asteroid, making it easier to land, and its poles are thought to hold vast amounts of water ice. That potential volume of water has made it the focus of NASA's Artemis program, which aims to land astronauts on the moon's southern pole, and also make the space agency a critical first customer for any water harvested on the moon.
China, India, Israel, the US, Europe, everyone is now sort of focusing on the moon.
이러한 프로젝트를 추진하는 국가로는 중국, 인디아, 이스라엘, 미국, 유럽 등이 있습니다.
And all of these government programs are looking to set up shop for a water mining future. A fueling station on the moon could ultimately make current space ventures much cheaper and make future space missions possible. Although entirely theoretical at this point, here's how it could play out. Water is mined on the moon and a fueling
아직은 이론에 불과하지만 달에서 물이 마이닝 될 것이고 이를 이용한 연료 스테이션이 셋업될 것입니다.
station is set up. This would provide the first customers, most likely government agencies, with water for human consumption and fuel.
이러한 물과 연료를 소비하는 첫 번째 소비자는 정부 기관이 될 것입니다.
For spacecraft. Water-derived fuel could also be harvested on an asteroid. Vehicles or propellant transports then carry the fuel from the surfaces to a stable storage point between the Earth and the Moon.
광물을 채취해서 지구와 달 사이에 있는 스토리지 포인트에 저장하게 될 것입니다.
Fueling stations can also be set up in low Earth orbit, making it accessible to satellites and other spacecraft.
이러한 연료는 인공위성과 다른 우주선에도 공급할 수 있을 것입니다.
As of now, satellites that run out of fuel are decommissioned. Extra fuel would allow them to stay in their orbits, increasing their lifespan.
이러한 연료 공급은 인공위성의 수명을 늘리는 데 기여할 것입니다.
Since using a rocket to get fuel out of Earth's atmosphere is expensive, refueling in low Earth orbit can greatly improve the size, type, and cost of missions in space.
지구의 낮은 저궤도에서 연료를 재주입하는 것은 로켓 발사 비용을 크게 줄일 수 있을 것입니다.
The commercial launch industry like SpaceX would also benefit from these fuel depots. The use of lunar-based propellant and commodities may also provide a stepping stone for interplanetary exploration.
이러한 연료 스테이션은 행성 간의 여행에도 크게 도움이 될 것입니다.
But while there has been a renewed interest in the moon, it hasn't been easy. In just 2019, missions to the moon's surface by both India and Israel resulted in landing failures.
달 탐사에서 인디아와 이스라엘은 랜딩에 실패했습니다.
And the technology to mine and extract these potential water reserves on the moon and beyond is still unproven, but some entrepreneurs are still optimistic.
여러 가지 문제들에도 불구하고 우주 계획에 긍정적인 기업가들이 있습니다.
The answer is yes. The technology exists. We can put something together, we can send something to the moon that can mine water. So we are sort of like a trailblazers, trying to figure out what's going on the moon, what's below the surface.
Meet Honeybee Robotics.
하니비 로보틱스라는 회사는 나사의 화상 탐사 등에서 필요한 드릴을 만들었습니다.
They've designed drills used in NASA's past Mars missions and have sampling and mining systems going on future planned missions to the Moon, Saturn's moon Titan, Mars' moon Phobos, and Jupiter's moon Europa.
We've been focusing on developing high-end, fully autonomous drilling systems.
이들은 높은 수준의 자율 드릴링 시스템을 개발하고 있습니다.
From literally iPhone size all the way to the size that cannot fit inside this vacuum chamber behind me.
And that's why NASA has long relied on their expertise. Unlike your everyday drill from the hardware store, their drills overcome the numerous limitations of space, which include extreme temperatures and low gravity.
극한의 온도와 낮은 중력에서도 동작하도록 만들어졌습니다.
That means you have to be very, very imaginative, very innovative to solve these problems. You're essentially trying to do what we do here on Earth, but with a fraction of the power.
이런 일을 하려면 상당한 상상력이 필요합니다. 지구에서 쓰는 파워의 몇 분의 1로 일을 해내야 됩니다.
With a fraction of the mass, with a fraction of the volume, and drilling is unforgiving. If you get stuck, if something goes wrong, there is no second chance.
드릴링에서 뭔가 잘못되면 두 번째 기회는 없습니다.
By giving out multiple contracts, NASA reduces the cost for themselves and the entire industry.
We want to have numerous providers that are competing against each other on cost and innovation, driving down the cost and increasing access to space and industrializing.
나사는 기업들 간의 경쟁을 통해서 가격을 낮추고 품질을 올리는 전략을 사용하고 있습니다.
Startup TransAstra, with a new infusion of $2 million from NASA, has teamed up with other space startups and educational institutions to prove its process for harvesting and utilizing water from asteroids without even touching them.
나사는 소행성에서 물을 얻고 이용하는 것에 대해서 스타트업과 인스티튜션과 협력하고 있습니다.
Optical mining is our patent-pending process for using highly concentrated sunlight or light from another source to excavate the surface without having to use digging tools to dig into it.
옵티컬 마이닝으로 굴착을 하는 방법은 현재 특허 출원 중에 있습니다.
And this is very important in space, especially for asteroids.
To help develop and prove this technology, they've teamed up with the Colorado School of Mines. It's known as the Optical Mining Testbed.
콜로라도 대학과 함께 옵티컬 마이닝의 테스트베드를 만들고 있습니다.
First, they put the simulated asteroid in a vacuum chamber to recreate the conditions of space. Then, they use liquid nitrogen to cool a surface inside the tank called a cryotrap. Then, they turn on a giant light bulb, which imitates sunlight that they then concentrate into a beam.
태양을 흉내내는 거대한 광원을 사용해서 이것을 한 군데 집중시켜서 빔을 만듭니다.
Resulting in very high temperatures. The beam of light hits the asteroid target, fractures the sample, and then water and other materials are released and frozen onto the cryotrap.
대단히 높은 온도에서 소행성의 물질은 부서지고 물과 다른 머티리얼들이 릴리스됩니다.
The volatile materials, which include water, methane, carbon dioxide, other valuable materials that are common and cheap here on the ground, but very valuable in space, trapped.
우주에서 아주 소중한 물질들이 밖으로 나오게 되고 그것이 우리가 원하는 곳에 트랩됩니다.
On our cryotrap. Well, that's pretty nice. The same way that we would trap those chemicals in space for a real asteroid mining mission.
이러한 방식을 우주에서 광물 채집에 활용할 수 있습니다.
Optical mining bypasses the daunting task of trying to land on an object with such low gravity that it could simply break apart when touched, and there's no drill to potentially get stuck.
이러한 방식은 중력이 낮은 곳에 착륙할 때 생기는 어려움도 없고 드릴을 파다가 스톡되는 문제도 없습니다.
But for this to work, they're targeting smaller asteroids the size of a beach ball for their tech demonstrator model, with plans to accommodate rocks the size of a cubic tennis court and bigger in future models.
We think the right thing to do is to rendezvous with the asteroid, match rotation with it, put a thin film bag around it, cinch that bag down, and then de-spin the asteroid. And now you have the asteroid in a container, so you can work with it in a practical way.
이 방식은 애스트로이드를 컨테이너에 넣는 방식인데 애스트로이드가 작고 느릴 때만 사용할 수 있는 방법입니다.
TransAstra believes that harvesting water on asteroids will not only make space travel more affordable for private industry, but it will make NASA's proposed missions to take astronauts to the Moon, Mars, and even asteroids possible within a budget that the US Congress may be willing to provide.
이러한 방식은 우주 미션에 드는 비용을 크게 줄일 것으로 기대하고 있습니다.
Now we can cut out hundreds of billions of dollars and actually make it possible for NASA to do all those exciting missions in a period of just 20 years or so by harnessing the asteroids. Now what's really cool about it is that by using public-private partnership and working with companies like TransAstra, the infrastructure for space resource harvesting and commercial transport in space can be developed.
이러한 기술을 바탕으로 우주에서의 상업적 개발이 가능해질 것입니다.
So by NASA doing it this way and NASA becoming the first user of these resources and this infrastructure for its exploration missions, then that infrastructure is left behind for industry. And that can create massive industries in space. Like it even becomes cost effective to build a space hotel.
상업적인 스페이스 호텔을 짓는 것도 가능하게 될 것입니다.
Transastra and partner Momentus will be on a 2-year contract with NASA to build their asteroid mining and in-space transportation prototype called Mini-B to provide optical mining in space.
현재 나사와 우주 이동 수단에 대해서 프로토타입을 만드는 작업을 하고 있습니다.
We live in a very exciting time where we're going to be able to take that to space, and the resources of space are literally unlimited.
And those unlimited resources are what some universities are betting on. At the Colorado School of Mines, where Transastra does its optical mining research, they now offer a graduate degree in space resources.
콜로라도 대학은 우주의 자원을 활용하는 대학원 과정을 열었습니다.
Our space resources program is the first of its kind in the world. There is anticipated to be a growing number of jobs directly in space resources.
이 대학은 우주의 자원에 관련된 직업들이 많이 늘어날 것으로 기대하고 있습니다.
But the skills and practices of space resources can be applied to lots of other things.
And a huge benefit to space mining research is that a lot of this technology can be beneficial here on Earth.
좋은 점은 우주 기술의 많은 부분이 지구에서도 활용될 수 있다는 것입니다. 어펜딕스입니다. 지금까지 시청하신 것으로 이번 차수의 수업이 인정됩니다. 스페이스 마이닝 기술에 대해서 동영상을 계속 보도록 하겠습니다.
Like their 3D printer that uses materials on the Moon or Mars to make structures and is modelled after startup Icon's 3D printer that is used to make homes on Earth. Their penetrometer is a tool on the end of a robotic arm that's being developed to take measurements on the Moon, but has applications for mining companies. And even a rover in a lunar testbed that can drill and prospect for resources has its benefits.
There are places on Earth where mining companies and equipment manufacturers are looking at applying smart robotic systems in terrestrial mines. They could go into places that are not safe for humans. They could work in much more confined, toxic environments than a person could.
And one country is doing just that and hopes to leverage their expertise in robotic systems for mining remote, inhospitable locations that are almost Mars-like.
Recently, the administrator of NASA, when the head of the Australian Space Agency visited, was saying that the US is looking to Australia to be doing development in this area of extracting resources in space. One of the reasons why we in Australia want to get into this area is because of the strength of our mining industry, the strength of our mining automation, and the strength of our mining research. We see it as a way that Australia can establish a niche space capability.
Australia's high wages have caused some of the largest mining operations in the world to seek cost savings by using automation. Rio Tinto, the world's second largest mining company, has fitted operations in Australia with fleets of autonomous trucks, drills, and even the first driverless freight train network. Adapting these technologies could prove useful to space programs, and the use of space technology in mines, such as robotics, would be useful on Earth. The Australian Centre for Space Engineering Research at the University of New South Wales in Sydney was founded in 2010 and has 15 PhD current or graduated students researching space resource ventures related to Australia's needs and expertise.
What we are trying to do at the moment is to reduce the risk perceived by a large company, mining company for instance, when they approach this type of venture. I think one of the main reasons that terrestrial mining companies should be looking at this problem is that they will benefit their terrestrial operations by learning some of these lessons. So if they look at the way that you need to automate on the Moon, that will help their terrestrial operation. If you look at the way you would analyse risk for this type of mine, they must learn new lessons which should hopefully flow back to their risk analysis for terrestrial mines.
Although mining companies have terrestrial mining expertise and monetary advantages, only time will tell who will be the first to provide a fueling station in space.
In terms of making it happen, I actually don't think it'll be a startup, I don't think it'll be a space agency, and I don't think it'll be a mining company, but I think it will be a big company, probably driven by a high net worth individual. A company like Blue Origin, SpaceX, a company like that. Not necessarily them, but something like that.
Proving that this kind of mining is feasible could trigger an influx of profit-minded companies migrating off the Earth. Just one industry that would stake a claim on the vast wealth of space. Not only is the universe a place for exploration, for private companies it's a new resource. The key which will unlock new possibilities in technology, manufacturing, living and working, both at home and beyond Earth. And all of this will be the result of our next giant leap.